Good morning, students. Today we are going to see Introduction to Screwed Fastenings. So this lecture is for the subject Machine Drawing. The subject code is SEMI 2001. So I am Dr. R.K. Selvakumar, Associate Professor Senior in the School of Mechanical Engineering, Assistant Director Placement and Training, Vellore Institute of Technology, Chennai, Tamil Nadu, India. So first we will see introduction. So before we are starting what is screwed fastenings, we have to know what is fastener. So a machine element used for holding or joining two or more parts of a machine or structure is known as a fastener. So it has to hold or join two or more parts of a machine or structure. So that is known as a fastener. The second one is what is fastening. So the process of something. So joining the parts is called fastening. So the process of joining the parts is called fastening. So we are having different types of fastener. One is permanent and the another one is removable or temporary. So these are the main two types of fastener, permanent and another one is removable. So permanent means you know about rivets and welds. So riveting and welding, this two process. So if we are making the fasteners by rivets and welds, then it is known as a permanent one. That means it's a lifetime. So when you want to remove the material, you can remove the material, but both the parts will fail, or any one of the parts will fail. So if you want to remove, then automatically any one of the parts will fail. So this kind of fasteners are known as permanent fasteners. So it's only we are calling it as a lifetime. So the second one is temporary. So screwed fasteners. So you can see that bolts, studs, and nuts and combination of this, and then machine screws, set screws, keys, cotters, couplings. So all these things are used as a temporary fasteners. So the main purpose of these things are for fastening the components that require frequent assembly and disassembly. So you can assemble and disassemble if you are using a temporary fasteners such as bolts, nuts, and machine screws, set screws, keys, cotters, couplings, etc. So, so these are the two major divisions of the fasteners: permanent and temporary. So once again, if the permanent rivets and welds means it's a lifetime one. If you want to remove one, you cannot remove like temporary fasteners. So definitely the permanent fasteners will fail any one of the part or both the parts. So the screw fasteners are used for what are the purpose? So the number one is to hold parts together. So as we said that permanent and temporary fasteners. And the next one is to adjust parts with reference to each other. So if you are adjusting, so we can use the fasteners. And the third important one is to transmit power. So these are the major areas or the screw fasteners are used. One is to hold parts together, second one is to adjust parts with reference to each other, the third one is to transmit power. So threaded fastener, as I said, it's a mechanical fastener used to join together two or more parts. So a threaded fastener is a mechanical fastener. It's used to join together two or more parts. So join together two or more parts. Okay. So threaded fasteners are formed. So how they are forming the threaded fasteners? One is a tapping tool for internal threads. So I will explain what is tapping tool or a tap in the later session. And a die. So for external threads. So also I will explain later. And the third one is a machine tool for either internal or external threads. So the threaded fasteners are formed using one is tapping tool, that is for internal threads, and second one is die for external threads, or machine tool for either internal or external threads. So screw thread nomenclature. So if we see external threads, so these are the terms we have to understand for better designing a screw thread. So the body, axis, and minor diameter, major diameter, pitch diameter, chamfer, or root, depth, crest, and included angle, or is it thread angle, threads per inch. So these are the some of the terms. We are having so many terms. Maybe we are going to see one by one. This is the external thread. So some of you may have a doubt on what is that external thread means. Okay. Anyway, you have come across so many threads in your day-to-day activities, but a screw thread on the outside of a cylindrical or conical surface. So if you see that, consider this as a cylinder or a conical surface. So if a screw thread is on the outside of a cylindrical or conical surface, then this is known as external thread. The screw thread on the outside of a cylindrical or conical surface. We understand what is external thread now. So now we will move to internal threads. So this is a schematic diagram of internal threads. So this is a tap drill, we will say. So before making any internal threads, we will first put a drill. So that one we will call it as a tap drill, which is lower than the diameter of that particular major diameter of the internal thread. So these are the terms similar to the external threads. You're having an axis, a root, crest, and pitch, major tap diameter and minor tap diameter. So now you'll have the screw thread on the inside of a cylindrical or conical surface is known as, yeah, you are right, it's known as internal thread. So for better understanding, as I told you that I'm going to take any one of the thread profile and I'm going to explain the terms which are in the screw thread nomenclature. So here I'm taking the external thread for better understanding. So you can see the first term, the longitudinal center line. So there is in the sketch, this one, yeah, the longitudinal center line that passes through the screw thread cylinder. This particular thing, the longitudinal center line that passes through the screw thread cylinder is known as axis. So you can see now, so this is the longitudinal center line. Passes through the screw thread cylinder is known as axis. That's the first term. The second one is the angular relief at the last thread. So if you see the diagram, the last thread is this one. So now the angular relief at the last thread, so that particular position that allows easier engagement with the mating part. This one already I discussed in the class. By seeing the profile itself you can say what is the term. Anyway, the angular relief at the last thread allows easier engagement with the mating part is known as chamfer. This one we discussed in the class so many times. What is chamfer, what is round, what is fillet, so many things. So this is the thing in a screw thread form. So you have to know this term also, chamfer. The next one is the peak or top surface of a screw thread. So if you see everywhere there is a peak is there. So if you see the diagram, this one, okay. So the peak or top surface of a through thread is known as crest. So this is a term you have to know when you come across any screw thread. So axis, it's the longitudinal center line that passes through the screw thread. Chamfer, the angular relief at the last thread. So it should allow easier engagement with the mating part. The third one is the crest, the peak or top surface of a screw thread. So next one, the next term, the bottom of a screw thread cut. So if you see in the diagram, so this one. So everywhere, no, not everywhere. In this diagram, we are having so many bottom of a screw thread cut. So in this one, the bottom of a screw thread cut into a cylinder, this one is known as root. So you can see this. It's known as a root. So the next one is the distance between the crust and the root. So you know what is crust and you know what is root now. So of a thread. So crust means you know that the top surface of the thread. So it should measure in a normal to the axis. That is very important. So if you see this, so you can see one root is there and one crust is there in the element or in the thread. So this one is known as depth, otherwise known as height. So again I'll see, you can see one root and then one crust is there, and it should be measured normal to the axis. That is very important. So that is known as depth. Next one is the angle between the surfaces of two adjacent threads. So you can see here, so these are the two surfaces, you can see of two adjacent threads. So you can see this one. So the angle between the surfaces of two adjacent threads is known as thread angle. So again we'll read what is root, the bottom of a screw thread cut. So you know that you can see the diagram, and so the bottom of a screw thread cut into a cylinder is known as root. So depth or height means the distance between the crust and the root of a thread measured normal to the axis. That is very important. Normal to the axis is known as depth or height. This is the term what we are using, the thread, screw thread nomenclature. And the third one is thread angle, the angle between the surfaces of two adjacent threads. So you can see that that is known as included angle, otherwise you can see it as thread angle. So next one, the distance between corresponding points. So trying to say this, the distance between corresponding points on adjacent thread forms. It's a very important term. You used to ask me so many doubts on this. So what is P, what is P, what is P? So this is the thing, actually it's pitch. So again, for better understanding, so the distance between corresponding points on adjacent threads, these two, okay, measured parallel to the axis. You can see that lines measured parallel to the axis, it's known as pitch. So the next one is the diameter of an imaginary cylinder. So this one, so this line, so you can see that the diameter of an imaginary cylinder that is located equidistant, that is very important, that is compared to the peak and then root. So if you see that it's an equidistant between the major and minor diameter. So I will explain what is major and minor diameter. So this one, it is an equidistance between the major and minor diameter. This is known as pitch diameter. So you know what is pitch and what is pitch diameter. So this is the thing, the equidistance between the major and minor diameter. Major diameter is the peak one, and the root where it is coming, that is a minor diameter. So that is known as pitch diameter. So next one is the largest diameter of an internal or external thread. So if I was saying here, so these two, if you see, this is the largest diameter of an internal or external thread. So here I am using an external thread. So this value, distance, is known as major diameter. Similarly, so if you're coming across these two, that is the smallest diameter of an external thread here, even it can be suitable for the internal thread also. So the smallest diameter of an external thread, here I am using external thread figure. So it's the smallest diameter of an external thread is known as minor diameter. So again we can recollect it. Pitch means the distance between corresponding points on adjacent thread forms measured parallel to the axis is known as pitch. The pitch diameter is the diameter of an imaginary cylinder that is located equidistant between the major and minor diameter. Meters is known as pitch diameter. The third one is major diameter, that is the largest diameter of an internal or external thread is known as major diameter. The smallest diameter on an internal or external thread is known as minor diameter. So these are terms we are using in screwed fasteners and also in the thread nomenclature. So the number of threads in 1 inch. So if you see here, so you can see, you can refer these 2 points. The number of threads in 1 inch, it should be measured axially, that is parallel to the axis. The reciprocal of the pitch, that is reciprocal of this, the pitch. So you know that it's known as threads per inch. So the number of threads in 1 inch measured axially, the reciprocal of the pitch. So it's known as threads per inch. And other terms, so the distance a screw will travel when turned 360 degrees. That is, if you are for one revolution, if you are turning, so how much the screw will travel, that is called as lead. It's a very important term in the design of screw threads. The next one is a continuous and projecting helical ridge on a cylindrical or conical surface. So you can see continuous and projecting helical ridge on the figures. So on a conical or cylindrical surface, it's known as screw thread. So again, once again we can recollect it. So threads per inch means the number of threads in 1 inch. It should be measured axially, that is parallel to the axis, the reciprocal of the pitch. The lead means the distance a screw will travel when turned 360 degrees, that is for one revolution. Screw thread means a continuous and projecting helical ridge on a cylindrical or conical surface. So these are the nomenclature or the terms you have to know in screw thread. So what are the other screw thread nomenclature? So that, for example, terms are there. Side. So side in screw thread means the screw thread surface that connects the crust and the root. So already we have seen that. So if it is connecting the crust and the root, that is called as side. As I told you, tap, I will explain. The tap means a tool used to make threads in holes. So it's actually a tool which is used to make threads in holes. So next one, tap drill. So similar to that, a drill bit used to make a hole in metal before tapping an internal thread. So you have to know what is tap and what is tap drill. Tap means a tool used to make threads in holes, that's internal threads. Okay. Tap drill means a drill bit used to make a hole in metal before tapping an internal thread. So there are differences there. And thread form, the profile or shape of a thread cut into a cylinder. So the profile or shape of the thread cut into a cylinder is known as thread form. So next one is thread series. So we'll see this. The number of threads per inch for a given diameter is known as thread series. So next term is die. As I told you, I'll explain the later part. A tool used to form external threads are known as die. So these are the other terms: side, tap, tap drill, thread form, thread series, and die. So these are also the terms used in the screw thread nomenclature. So I want to say few things about this class. Today we have seen introduction about fastener, fastening, types, what is permanent and temporary fasteners, and screw fasteners are used, and threaded fasteners and how it is formed, tapping tool for internal threads, die for external threads, machine tool for both internal and external, and screw thread nomenclature, external threads. So all these terms we have come across. So axis, chamfer, crust, root, depth, and the thread angle. So these are the references you can go through for further information about screw fastenings and this screw thread nomenclature, and another one is the thread forms. So machine learning by Narayana or technical graphics communication by Gary. So these two things I have referred. So please stay home and save lives, because you know that COVID is increasing rapidly in India. So please stay home and save lives. So thank you.